The most powerful telescope in history, the James Webb Space Telescope, is serving its purpose by providing us with exciting new insights into the early stages of the universe and our own origins. Recently, researchers have discovered 6 megagalaxies that formed in the early universe when it was a hot, dense mixture. The James Webb Space Telescope has continued to explore and examine these discoveries, and each observation reveals even more distant and ancient galaxies, each with unique characteristics. However, the most striking discovery is the detection of organic material, including the building blocks of life, in one of these ancient and primitive galaxies. This represents a breakthrough that transforms our understanding of the cosmos. Join us as we explore this incredible discovery made by the James Webb Space Telescope and what it could mean for our future. If you're interested in keeping up to date with views from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Astronomers using the James Webb Telescope have succeeded in detecting the most distant organic molecules known in the universe. This is the first time complex molecules have been found in the distant universe. These complex molecules were found in a galaxy called SPT 0418-47, located at a distance of more than 12 billion light-years. Given that the universe is approximately 13.7 billion years old, this galaxy is extremely old. The structure, resembling a cosmic smoke ring, reveals the presence of complex organic molecules similar to smoke or smog. This discovery provides information about the chemical interactions that occurred in the earliest galaxies and their relationship to star formation on Earth. These molecules, known as polycyclic aromatic hydrocarbons, are found in smoke, soot, smog, engine exhaust, and forest fires. Organic molecules are based on carbon, considered one of the building blocks of life, as it is an essential element in the amino acids that make up proteins. Light from this dusty galaxy began its journey across the cosmos when the universe was less than 1.5 billion years old, which is only 10% of its current age of 13.8 billion years. Using the James Webb Telescope's infinite capabilities, which can detect light invisible to the human eye and penetrate cosmic dust, new details about the galaxy were captured. In addition, the space observatory benefits from a phenomenon known as gravitational lensing. This phenomenon occurs when two galaxies are almost perfectly aligned from our perspective on Earth, causing the light from the background galaxy to be deformed and magnified as it passes near the foreground galaxy, forming a ring known as an Einstein ring. Gravitational lensing was originally predicted by Albert Einstein in his theory of relativity. Thanks to this increase in magnification, we can observe in detail the components of a galaxy in the early universe that we cannot otherwise see. During a thorough analysis of the data from the Webb telescope, astronomers detected the signature of organic molecules in an unexpected way. This surprising discovery is helping astronomers answer some of the most fundamental questions about the origin of the universe. It is amazing that scientists can identify molecules located billions of light-years away that are similar to those we know here on Earth, but are often associated with undesirable forms such as smog or smoke. Since its launch, the James Webb Telescope has been in the news for its observation of miles of colossal galaxies. Now, the James Webb Telescope has made shocking new discoveries that could completely change our understanding and require a thorough overhaul of all our cosmological theories. These groundbreaking discoveries could have a significant impact on our current knowledge, continuing a series of discoveries questioning the Big Bang. The James Webb Space Telescope has found the most distant cluster of galaxies ever observed, at a distance of 30 billion light-years. According to the researchers, this cluster is possibly one of the largest in the universe today. Although the 7 galaxies that make up the cluster had previously been observed with the Hubble Space Telescope, scientists did not have precise information about their distance or whether they were actually bound together as a group. Because of the time it takes light to travel from these distant objects to the position of the JWST telescope in orbit around the Sun, we are observing these galaxies as they were approximately 650 million years after the Big Bang. The present form in which we see the protocluster gives the impression of being small. However, if we could observe it instantaneously without the limitation of the speed of light, it would most likely appear colossal, capable of exerting a gravitational pull on thousands of galaxies. Simulations by researchers suggest that this protocluster could be one of the largest clusters in the universe today. Recently, The JWST telescope also made a surprising discovery when it found a tiny galaxy that existed 13 billion light-years ago and has been developing stars at an exceptionally high rate relative to its tiny size. This is believed to be the smallest galaxy ever discovered at this distance, approximately 500 million years after the Big Bang. In a groundbreaking finding, a team of researchers from the University of Minnesota used the JWST telescope to peer more than 13 billion years into the past and discovered an extraordinarily tiny galaxy that has been developing stars at an extremely fast rate given its dimensions. This tiny galaxy is beyond the capability of all telescopes except the James Webb, and the first observation of this distant galaxy are truly impressive, said Patrick Kelly, lead author of the study. Although the galaxy is about 1/1,000,000th the volume of the Milky Way, it is amazing that it continues to form the same number of stars each year. It's a fascinating phenomenon. If you're wondering how the James Webb Telescope can observe such minute details in a field wide enough to capture the entire galaxy cluster at once, don't hesitate. The field of view of the legendary James Webb Telescope is wide enough to capture the entire galaxy cluster at once. This is mainly due to a phenomenon called gravitational lensing. Gravitational lensing uses lenses that bend and magnify the light from the mass present in the galaxy or galaxy cluster. Gravitational lensing has played a crucial role in making this small galaxy appear 20 times brighter than it really is. In fact, this may be the first time we have had the opportunity to observe such a distant part of the universe, almost to the very moment of the Big Bang. The JWST telescope, with its exceptional ability to track galaxies, has made this task easier than ever before. Until now, we have had only 2 space observatories capable of creating deep-field images that allow us to see the universe in unprecedented detail: Hubble and James Webb. Hubble operates in the visible light range, while Webb focuses on the infrared. Although both capture images of distant galaxies in dimly lit areas of the sky, the Webb images are sharper because of their infrared capabilities. When we compare the deep field captured by each of these telescopes, we can appreciate their remarkable differences. The Webb images have their own distinctive look compared to those from Hubble, most evident in the appearance of stars with their distinctive pointed diffraction peaks. These peaks are unique features of the Webb images because of the shape of its mirror. Webb's ability to observe objects in the infrared gives it a significant advantage over other space telescopes, including its predecessor, Hubble. Many objects that remained hidden or inconspicuous in Hubble's deep-field images are now being revealed, literally, by Webb. If things turn out this way, 2023 is likely to be full of discoveries that will change our understanding of the cosmos. But who can predict with certainty what is to come? The James Webb Space Telescope, JWST, a marvel of modern astronomy, continues to unveil the mysteries of the universe with each passing observation. Launched with the goal of exploring the cosmos in unprecedented detail, the JWST has already made significant discoveries that challenge and expand our understanding of the universe's origins and evolution. One of the key capabilities of the JWST is its ability to detect faint infrared signals from objects that are billions of light-years away. This capability allows astronomers to peer back in time and observe galaxies as they were when the universe was young, just a fraction of its current age. By studying these ancient galaxies, scientists hope to unravel the complex processes that led to the formation of stars, galaxies, and ultimately, life itself. In recent observations, the JWST has focused its gaze on a region of the sky known as the Hubble Ultra Deep Field, HUDF, where some of the faintest and most distant galaxies ever observed reside. These galaxies, located billions of light-years away, offer a glimpse into the universe's infancy, revealing the conditions that existed shortly after the Big Bang. By analyzing the light from these distant objects, astronomers can study the chemical composition of the early universe and track the formation of heavy elements like carbon, oxygen, and nitrogen. One of the most intriguing aspects of the JWST's discoveries is its detection of organic molecules in distant galaxies. Organic molecules are the building blocks of life as we know it, and finding them in the far reaches of the universe suggests that the ingredients for life may be widespread throughout the cosmos. The JWST's ability to detect these molecules in such distant and ancient galaxies provides valuable insights into how life could have emerged on Earth and whether similar conditions exist elsewhere in the universe. In addition to studying individual galaxies, the JWST is also equipped to investigate larger structures known as galaxy clusters. These clusters contain hundreds or even thousands of galaxies bound together by gravity, making them the largest gravitationally bound structures in the universe. By studying galaxy clusters, astronomers can learn more about the distribution of dark matter, a mysterious substance that makes up about 27% of the universe's mass-energy content. One of the JWST's most ambitious projects is to study the formation and evolution of planetary systems around distant stars. Planetary systems like our own solar system are thought to form from disks of gas and dust surrounding young stars. By observing these disks with the JWST's infrared instruments, astronomers hope to better understand the conditions under which planets form and the factors that determine their composition and habitability. Another area of focus for the JWST is the study of exoplanets, or planets that orbit stars outside our solar system. Since the discovery of the first exoplanet in 1995, astronomers have identified thousands of these distant worlds, ranging from small rocky planets to massive gas giants. The JWST's advanced instruments will allow scientists to study the atmospheres of exoplanets in unprecedented detail, searching for signs of water vapor, carbon dioxide, and other molecules that could indicate the presence of life. In addition to its scientific discoveries, the JWST is also pushing the boundaries of technology and engineering. The telescope's primary mirror, which spans 6.5 meters, 21 feet, in diameter, is the largest ever launched into space. To fit inside the payload fairing of the Ariane 5 rocket that launched it into orbit, the mirror had to be folded up like a piece of origami during its journey to space. Once deployed, the mirror's segments unfold and adjust to form a precise optical surface capable of capturing incredibly sharp images of distant celestial objects. The JWST's instruments are cooled to temperatures close to absolute zero, -273 degrees Celsius or -459 degrees Fahrenheit, using a giant sunshield the size of a tennis court. This extreme cooling is necessary to reduce the telescope's own infrared emissions, allowing it to detect the faint signals from distant galaxies and exoplanets. The sunshield also protects the JWST from the heat of the Sun and Earth, ensuring that its sensitive instruments can operate at peak performance. Despite its technical challenges, the JWST has already begun to revolutionize our understanding of the universe. In just a few short years of operation, the telescope has produced stunning images of distant galaxies, star-forming regions, and planetary systems. These images not only inspire wonder and awe but also provide valuable data for astronomers to study the processes that shape the cosmos. Looking ahead, the JWST promises to continue making groundbreaking discoveries in the years to come. Its ability to observe the universe in infrared light will allow astronomers to study objects and phenomena that are invisible or obscured in visible light, such as dusty regions of star formation and the atmospheres of distant planets. By combining its observations with data from other ground-based and space-based telescopes, the JWST will provide a more comprehensive picture of the universe's history and evolution. One of the JWST's primary goals is to study the first galaxies that formed after the Big Bang, known as cosmic dawn. These ancient galaxies, which existed more than 13 billion years ago, are believed to have played a crucial role in the reionization of the early universe, when the first stars and galaxies began to emit light and heat. By studying these galaxies with the JWST's infrared instruments, astronomers hope to learn more about the conditions that existed during this pivotal period in cosmic history. In addition to studying ancient galaxies, the JWST will also investigate the properties of black holes, mysterious objects that exert a gravitational pull so strong that not even light can escape from them. Black holes are thought to reside at the centers of most galaxies, including our own Milky Way, and play a key role in regulating the growth and evolution of galaxies over cosmic time. By studying the motion of stars and gas around black holes, astronomers can learn more about their properties and how they influence their surrounding environments. Another area of interest for the JWST is the study of supernovae, explosive events that mark the deaths of massive stars. Supernovae release enormous amounts of energy and matter into space, enriching their surrounding environments with heavy elements like iron, nickel, and silicon. By studying these cosmic explosions with the JWST's sensitive instruments, astronomers can learn more about the processes that govern stellar evolution and the formation of the elements that make up planets and living organisms. The JWST's ability to study the atmospheres of exoplanets is also of great interest to astronomers. By analyzing the light that passes through an exoplanet's atmosphere as it transits in front of its parent star, astronomers can determine the composition of the atmosphere and search for signs of life, such as oxygen, methane, and water vapor. This technique, known as transmission spectroscopy, has already been used to study the atmospheres of several exoplanets, including some that may be potentially habitable. In addition to its scientific goals, the JWST is also a testament to international collaboration and cooperation. The telescope is a joint project of NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, with contributions from scientists and engineers around the world. By pooling their expertise and resources, these organizations have been able to overcome technical challenges and build a telescope that promises to revolutionize our understanding of the universe. The JWST's discoveries are also inspiring a new generation of scientists and engineers to pursue careers in astronomy and space exploration. By showcasing the beauty and complexity of the cosmos, the telescope is helping to spark interest and curiosity in people of all ages about the mysteries of the universe and our place within it. As the JWST continues to collect data and make new discoveries, astronomers are eagerly anticipating the wealth of information that will be gleaned from its observations. From the formation of the first galaxies to the search for signs of extraterrestrial life, the telescope is poised to uncover secrets that have eluded scientists for centuries. In conclusion, the James Webb Space Telescope represents a triumph of human ingenuity and determination. By pushing the boundaries of technology and exploring the universe in unprecedented detail, the telescope is expanding our understanding of the cosmos and our place within it. With each new discovery, the JWST is rewriting the textbooks of astronomy and inspiring future generations to continue exploring the wonders of the universe.